So in the last video we took some readings around this building and we recorded them on our level book, and as I said before, this is a rise and fall level book. So what I want to show you in this video is how we take these seemingly random figures and actually get something we can actually use out of them. So the process is, what we do is, this first figure here, we take away the second figure, and if the answer is a positive figure, it goes in the rise column. If it's a negative figure, it goes in the fall column. So 2.395 minus 2.050 is going to give us 0.345. That's a positive, so it goes in the rise column. Next step, we take 1.970 away from 2.050. So that gives us 0.080 mil difference. Again, a positive. So it's still in the rise column. 1.970 minus 1.888 gives us a difference of 82 mil. It's still positive, so 0.082. 1.888 minus 1.808 is going to give us a difference of 80 mil, or 0.080. Still a positive, so still in the rise column. Keep working our way down. We end up difference of 86 mil here. Next one's a difference of 58 mil. And 1.664 minus 1.690. It's going to give us a difference of 55 mil. And the next one is a difference of 75 mil, 0.075. Now when we get to here, we do this one minus this one, which is in the first set of readings. So 1.534 minus 1.493 gives us a difference of 41 millimeters. Okay, so now it gets a little bit tricky because this is our change point. So now we forget about these figures. We're just going to switch over and start back here. Use this figure and take it away from, take this figure away from this figure here. So 1.732 minus 1.795. That will give us a negative, because this number here is bigger than this number. There's a negative of 63 mil. So because it's a negative, it goes in the fall column. So 0.063. And we keep working our way down. So this one minus this gives us a negative again of 64 mil. Okay. So that minus that gives us a negative of 77 mil. That minus that gives us a negative of 76 mil. That minus that gives us a negative of 40 millimeters. That minus that gives us a negative of 81. That minus that is just a negative of 83. So all the negatives in the fall column, and that minus that gives us a negative of 73 mil. 0.073, and that minus that gives us a negative of 345 mil, so 0.345. Okay, so there's all our initial working out done. So we know which ones are rising, which ones are falling. Now we can do a quick check just to make sure we're on the right track. So first two checks we can do, we can add these two up. So 2.395 plus 1.732 gives us 4.127. We can add these two up, 1.493 and 2.634. It also gives us, sorry about that one, and that also gives us 4.127, which is what we wanted. Actually, sorry, that should be up there. Where is it? Can't paste that in there. Some old formulas coming back. So those two are the same. So the difference between those is obviously 0, which is what we want because this is a closed survey and we started at the same point that we finished. The difference in elevation over the total survey should be 0. That's good. So the next thing we can check is our rise and fall. So if we add up all of these, we actually come up with 0.902. So over the total survey, we had a rise of 902 mil. And if we add up all the falls, don't worry about the fact that they're negatives, just add them up as if they were positives. We end up with a 0.902 difference as well, which is good because then the difference for that one is 0, so that's fine. So far we got 0 for those two, a 0 difference on these two. Let's put 0 in there. The spreadsheet's not showing zeros, so it's disappearing. And that's what we want. So everything's right so far. So now we're actually going to work out what the actual height is. So we knew what the RL was 10 meters at the start. Well, the datum was 10 meters. We had that written on our sheet. And it was also on the site. So now what we have to do, anything in the rise column gets added. Everything in the fall column gets taken away. So 10 plus 345 is obviously going to be 10.345. So that's the RL of our station 1. Now what we do is we take our 10.345 and add the next line down. So add 80 mil. So that's going to become 10.425. So then again 10.425 plus another 82 mil. It's going to give us 10.507. 10.507 plus 80 mil is 10.587. 10.587 plus 86 is going to be 10.673. 10.673 plus 58 mil is 731. 10.731 plus 55 is going to be 10.786. Then we plus 75 is going to be 10.861 plus 41 gives us 10.902, which is good because 902, that was our total rises. Now, this next one is in the fall column, so 10.902 minus 63 is going to give us 10.839, well, 39, and minus 64 will give us 10.773. 10.775 minus 77 will give us 10.698. 10.698 minus 76 equals 10.622. Take away 40 equals 10.582. Take away 81 is going to give us 10.501. 10.501 minus 83 will give us 10.418. Minus 73 will give us 10.345. And 10.345 minus 0.345 will give us 10 meters, which is good because that is back to our datum, and we know that the RL of our datum was 10 meters. So the difference between our first RL and our last RL is 0. So our spreadsheet or our level book works out, and it is correct, and our survey is accurate. So that's how we use a level book to work out our levels. So now we know that 0.3, for example, is 507 mil higher than our datum, or 0.9 is 902 mil higher than our datum. Okay, so that's the usefulness of a level book. Remember the 3 checks: add up your back sites, add up your foresights, and work out the difference. Add up your rises, add up your falls, work out the difference. And your first RL and your last RL, work out the difference of those. If you've done a closed survey, so you started at the same point that you finished, then your difference should be 0. If you didn't do a closed survey, it doesn't matter, just that you'll have a margin of difference. But that margin of difference should be the same for the first check, the second check, and the third check. Should be the same difference. That way the level book will still be accurate. So there we go. That's how we use a rise and fall level book to work out our levels. In the next video, I'll show you how to use the height of collimation level book to work out the same figures.